This video demonstrates the contact analysis. We need to import the geometry, pick on the file, import CAD geometry. Under the geometry, ensure that the step format is now selected. You can browse for the file from where the step file need to be imported. In this case, the file is already existing in the recent history. Pick on that file, pick on import. The CAD geometry is now imported. Visualize the model in the shaded mode. Set the isometric view of the model. It can be observed from the model that there are two components in the components folder. The first one is U and second one is U.1. You can switch on and switch off the respective geometry. In this analysis, the two bodies are made up of two different materials. The first body, which is made up of aluminium, and the second body, which is made up of steel. Let us begin with meshing of these models. First, create one component where 2D elements need to be organized. Right-click, create a component. Give the name of the component as 2D elements. Specify a desired color. For that, in this case, we will choose this color. Pick on Create. Ensure that 2D elements component is now created. In this, there are no elements and no geometry. Now, confirm that 2D elements component is also set to current here. Now, pick on F12 for the surface mesh. F12 represents mesh, surface. Pick on F12. Pick on the top surface and pick on the element size as 10, and elements to be created is quad. Elements to go to the current component, and the element should be of first order, and there should be a connectivity between the elements. Remember, the elements which will be generated on this face will go to the current component. The current component is 2D elements, which is highlighted in the bold color. Pick on Mesh. These are the 2D elements created on the surface. Pick on Return. Pick on the shaded mode of the elements to visualize the elements. Now, reset the surface. Pick on this face for meshing. Pick on the mesh again using the default parameters. Mesh. The elements are now created. Pick on Return. You can observe that we have created a 2D elements on two components. These 2D elements now exist in a same component. Now pick on Return. These elements should be dragged along the length. The length of this model is 30 mm, or the depth of this model is 30 millimeters. For that, we use the command called as 3D drag. In the drag, we have to drag the elements and reset the element. Pick on any one of the element here, right click, pick on by face. These all elements will be dragged in this direction, that is X direction, to create the solid elements. For that, we need to create the component in which these solid elements should go. For that, create a component here, right click, create component. Name of the component is 3D elements and it is for steel. Specify the desired color for that. Pick on this color and use the card image for that as HMComp. Pick on create. Now the 3D elements steel is active. Pick on the return. Now pick on the 3D here. Under 3D, pick on the drag. The drag elements option is now highlighted. Reset the element and pick on this element. Right click on this, pick on by face. Now the elements of that face are completely selected. The distance to which it need to be dragged is 30, and on the drag we need to have 6 number of divisions, and it should be dragged in the positive X direction. Hence specify X axis. Pick on drag. You can observe the solid elements are now created, which are in the component 3D elements for steel. Pick on return. Similar to the previous case, create one more component which take the 3D elements of aluminium block. Right click, create a component. Name of the component 3D elements aluminium. Specify the card image as HM component, and the color of that will be of this green color. Pick on create. Since the card edit component upon creation is checked, which will prompt us to edit any details of the component. Right now we don't want to edit any parameter. Change it to return. Now drag the elements of these face in the downward direction, that is negative Z direction. Pick on 3D, pick on drag, elements to be dragged, reset the elements, pick on this top face, element, right click by face. Ensure that all the elements of this face are selected. These elements should be dragged in downward direction, that is Z direction. The distance to be -30, and on drag we want to have 6 number of elements. Pick on drag. The elements now created are in the component that is 3D elements aluminium, and they are highlighted in the respective color of the component. Pick on return. There exist the geometries and there exists a 2D elements collector. You can switch off and switch on the 2D elements to better visualize them. Now similarly, 3D elements for steel also can be visualized. Similarly, 3D elements from aluminium also can be visualized. When three components are not required, select the three components and pick on right click, delete those components. There is a confirmation window, pick on yes. These are the two models which need to be taken for the simulation or the analysis. It is mandatory to define what kind of element are these. For that, define a desired element type. Pick on Tools, pick on Element Type Table, pick on the new element type definition, and ensure that the element type number is 1. It is default. Element type name is taken as ET1, or you can change the name to solid. Select the element as solids. Under that, 185 need to be selected. Solid 185 is a hexagonal solid element. Pick on Create. Pick on Close. One element of solid 185 is created. Pick on Close. Now create a property for these two components. Pick on right click, create a property. The property is for the solid elements and give the name of the property as solid property. Enter the card image, that is the element type, as solid 185 and pick on Create. Now cancel the card edit property upon creation and pick on Create. Ensure that the property is now created in the tree, solid property. Now elements need to be updated to this property. For that, what we need to do is pick on 3D, element types. Under 2D and 3D, for hexagonal element, change it to solid 185, and for pentagonal elements, change it to solid 185. Now reset the elements, put the window to select all the elements. Pick on Update. Pick on each of the element from different components. Pick on Review. It can be seen the element type is now updated to solid 185. Define the material now. Right click here, create the material. The first material to be aluminium. Use All under Type and select the name of the material as aluminium. Pick on MP Data. Pick on Card Edit Material upon creation and pick on Create. Now we can edit the card by specifying its density, Young's modulus and Poisson's ratio. Under density, enter the density in the unit ton per millimeter cube and Young's modulus as MPa and Poisson's ratio as the unitless ratio. Pick on Return. One of the material is now defined, that is aluminium. Right click, create one more material. Give the name of the material as steel. Ensure that the card image is material property data. Card edit the material upon creation. Pick on Create. Density, Young's modulus, Poisson's ratio need to be added. Density being in ton per millimeter cube, Young's modulus in megapascal, and Poisson's ratio. Once the material property is defined, pick on Return. Now, update the components 3D elements steel and 3D elements aluminium with the desired property and material. Pick on the components here. Under the components window, pick on Update. Reset the components. Pick on this component, and this component is made up of steel. Hence, the material for this to be of steel. Property to be solid property. Right click here, select the solid property. Now, it will highlight that this component, the highlighted component, is having the card image of HMCOM with the property of solid property, and element is solid 185, and the material for this is steel. Pick on Update. Now you can see the component is updated. Similarly, reset the component and pick on this component. It has taken the card image as HM component. Since this component also is made up of solid elements, pick on the property as right click here, pick on solid property, and the card image is solid 185, that is the element type. Under the material, right click on this blank window and pick on aluminium. Pick on Update. Pick on Return. Pick on the components again to cross-check the component. This is steel. Reset. And this is aluminium. Reset. Pick on Return. Now, apply the desired boundary conditions and the load. For that, enter into the analysis. Pick on Constraints. I want to constrain the nodes in translation motion, that is, pick on any one of the node in this phase, and on this phase, right click, select all the nodes on that phase. Now, these nodes to be constrained in X, Y and Z direction in their translatory motion. Hence, select only those as fixed. Remaining all, keep them as free. Now, when the constraint is created, it should go in particular load collector. Currently, there is no load collector created. Right click, create a load collector. Load collector window is now open. Enter the load collector as fix and pick on Create. The load collector is now created and which is highlighted in bold, and that load collector is set as current. Now pick on Create. It can be observed that the small triangular symbols which represents these particular nodes are constrained in their translation X, Y, Z direction. Translation X represents number 1, translation Y represents number 2, and translation Z represents number 3. Hence it is 1, 2, 3 are constrained. Now apply the necessary boundary condition for the component that is aluminium, because the steel body is now constrained in all the direction of translation on this face. Aluminium body is not at all constrained. Pick on, right click here, create, pick on load collector. Give the name of the load collector as constraint. Pick on create. Now reset the nodes. Pick on this node. Observe carefully. On this whole body, I am selecting only one node, and this node should be able to translate in this direction. Means the whole body nodes related to this node will translate in the y direction only if I specify the translation motion to be free in y-axis, and I constrain the motion of this body, aluminium body, in vertical z direction and transverse x direction. Now pick on create. The constraint now is created that this node is restricted in x and z direction, that is 1 and 3. Number 2 constraint, that is y translation, is free, which can be seen from here. Now apply the force. Pick on return. Pick on analysis, force. The force need to be applied on the nodes. Reset the node and pick on this face and pick on this face. Right click, pick on by face. All the nodes are now created or selected. Create one more load collector. Right click, create load collector as force. Pick on create. I want to apply 1 Newton force in each of these nodes in the y direction, that is this direction. Select the y-axis as the direction of force and 1 Newton as a magnitude of force. Pick on create. The coordinate system, it is highlighting as local. Change it to global so that the force will be taken in the y direction. Pick on create. It can be seen that the force is applied in the y direction and the magnitude of force at each node is 1 Newton. Once the force definition is complete, the boundary conditions and loads are defined. Pick on return. Now it is the time to define the contact between two bodies. Pick on tools. Pick on contact manager. Contact manager window is now open. Pick on the new contact, and in the contact pair window select the contact type to be 3D. We would like to have a surface to surface contact. Pick on target here. It will ask to select a target body. In this case, the target is the steel since it is the stiffer compared to aluminium. Pick on this body. Pick on proceed. Only that body is now highlighted. Its color has been turned to red, which means the elements which are highlighted here are the outer elements of that particular component. Pick on the elements here and pick on this element. Right click, pick on by face. These elements are now included. Now pick on proceed. Pick Next. The target is now defined. Pick on Next. Now it is asking the contacting component. Pick on the component, pick on this component, and pick on Proceed. Pick on Next. It asks for the selection of elements for the contact body. Under the elements, pick on this phase and pick on Biphase. Pick on Proceed. Pick on Next. Now the contact definition is complete. Pick on the Next. Select again Next. Use the coefficient of friction as 0.15. Now pick on the Next. It is highlighting the element normals here. Accept these normals and pick on OK. Contact and the target is now defined in the Contact Manager. Pick on Close. You can observe that the elements where the contact is supposed to happen is being changed in their color. Now we need to cross-check whether the properties, element type, and the material is properly defined. Pick on Utility. Select the Component Manager. It is highlighting two components in red color, means their element type is not updated. Select those two components and pick on the element type reference number here and select the element type as Solid 185. Pick on Set. There is a confirmation window. Do you want to change the element set? Pick on Yes. Now close this window. Export this file to the solver. Pick on File, Export to the solver deck. The solver deck extension will be CDB. In this case, the solver is ANSYS and the template is selected as ANSYS. Export all the things of FE data. Pick on Export. You can observe it is showing the export is finished. Now open the solver. Change the directory of working where the FE data is saved. Pick on File, Change Directory and select the desired directory by browsing the particular folder. In this case, the directory is already set. Change the job name of the file. File, change job name as U. Lock. Pick on OK. Now read the FE data into the solver. Pick on File, Read Input From. Select the file as which is CDB file and pick on OK. The file is now imported into the solver. Pick on Fit and pick on Plot, Multiplot. View the 3D representation of the element or the model. Now, to visualize the boundary conditions and the loading, pick on Plot Controls, Symbols, use Applied Boundary Conditions, All, pick on OK. It can be clearly seen the direction of the force and the boundary conditions that are specified. To begin with the solver or solving process, we need to do some prerequisite, that is, pick on the solution and set the analysis type as new analysis. This analysis to be static. Pick on OK. Pick on solution control. This is the very important thing which need to be done during the contact analysis. Enter the time at the end of the step as 1. Ensure that the automatic time stepping is now on. Number of steps enter as 20. Enter the minimum steps as 10 and enter the maximum steps as 15. Pick on Enter. Now pick on Solution, Solve, Current Load Step. There is a confirmation window. Pick on OK. The solution began and it is a nonlinear solution, and there is a confirmation that solution is done. Pick on Close and cancel this window. This is the convergence plot of the contact analysis. Pick on Plot results now in the general post processor. Counterplot, Nodal solution. We would like to retrieve the deformation in the Y direction. Pick on OK. This is the Y direction displacement which has happened. You can animate this by picking on Plot Control, Animate the deformed result, that is the DOF solution in Y direction. Pick on OK. This is how the deformation has happened on the aluminium body. Pick on Close. Set a desired orientation of the model. Now the visibility is still clear that the force was applied in this direction. Animate it again. Plot Controls, Animate, Deformed Results. Pick on the stress and use von Mises stress. OK. Now clearly visualize the distribution of von Mises stress and its magnitude here. The speed of animation can be changed. Pick on Close. Set the orientation again. It can also be evaluated that what is the contact pressure between these two bodies. Pick on Nodal solution, under Contact, pick on the contact pressure. Pick on OK. There exists this magnitude of contact pressure between two bodies. The file can be saved, and which will be saved in the format .db. Thank you for watching this video.